Here we go. I'm also going to try very hard to let you know how my brain approaches these, how my brain thinks, because a big question students ask me is, well, Mr. Dewick, I'm fine once you tell me how to get going, but I have trouble figuring out how to get going. So, number one, they want me to find the coefficient of friction, so they want me to find mu, that there thing there, how sticky the ground is relative to this object. And when I read this, I noticed this phrase here. That's a physics phrase that I will always notice because it's very important. I think I'm going to do a free body diagram because there's more than one force here. We have gravity down. Actually, rather than do a separate free body diagram, I'm going to label the forces right on my diagram. It's not sinking into the ground like quicksand. It's not flying into you like Superman. I have normal force up. Here I have this 12. I'll draw an arrow there just to remind myself not to forget it. If you wanted me to give that 12 a name, that's what I typically call the applied force. Something's applying a force. What? I don't know, but it's 12 newtons. Why would this diagram here be impossible based on the information? Yeah. That's impossible to be a constant speed because of Newton's which law? First. Newton's first. Newton's first says if you're not accelerating, forces must be balanced. Okay? So there has to be a force this way, and that force, I'm pretty sure, is friction. And because we're at a constant speed, I can actually say friction equals F applied. Now, let me walk you through the whole procedure. If you didn't spot that, you would say, who's winning? Well, it's going to the right. I'm going to let F applied be the winner. I guess that means that friction is the loser, and you would say winner minus loser equals MA. But hopefully then you would go looking for the acceleration. Nick, you would be looking for a number with meters per second squared, and you wouldn't find one. So you'd freak out, or you'd say, I guess I better read a little closer. And then you'd spot the constant speed, and you'd say, oh, A equals 0. So really what I have is F applied minus friction equals 0, which means now you can plus the friction over, and you end up with what I said a few minutes ago, that F applied equals friction. Now, if you jumped straight to here, great. That would be my hope that you would spot that. But for what it's worth, Geo, if you did not, winner minus loser still gets you there. Just don't blindly stick numbers in. If I really wanted to be sneaky, Zach, I would have said being pulled at a constant speed of 6 meters per second, just to tempt people to put the 6 in for the acceleration, even though they'd be putting in a meters per second number in for a meters per second squared number. Hopefully your physics teacher has gone on a rant occasionally about the value of memorizing units and making sure you pay. Okay, good. Well, friction is mu times the normal force. I don't know the normal force. Oh, but look. I know another force that must be the same size as the normal force. Which force? Okay, so you're telling me I can go F applied equals mu mg. This question wants me to find mu. Hey, what's mu? I don't know. What's mu with you? So to get the mu by itself, how will I move the m and the g over? Because they're timesing. So if I hear you, you're telling me mu is going to be F applied divided by, I almost wrote a mu again, divided by mg. It's going to be 12 divided by 5 times 9.8. I wonder if I can do that in my head. You know what? It's not that and it's not that because it's less than 1. It's roughly 12 divided by 6, well, 12 divided by 50, which is 6 divided by 25. Is it? It's A, isn't it? Yeah. It's roughly 6 divided by 25. 6 divided by 24 is 0.25, so 6 divided by 25 is going to be a little less than 0.25. Some of you are like, Mr. Dewick, please show me. Okay, there's 2 things on the bottom, so I put the bottom in brackets. And there's your 0.244897, that there. For some reason, 2 marks. Oh, because there was a fair bit of work involved here. It was, if this was not a I stole this from an old provincial exam, by the way. Physics 12, I just snuck some in here. You guys didn't realize that, but that's from an old Physics 12 provincial exam. if I gave this to you as a written, this would absolutely be worth 2 marks because you had to do some serious number crunching here. Number 2, not a written question, but it's 2 marks, probably means multiple steps, probably means it needs a free body diagram. They want the acceleration. I see air resistance. This is a job for a free body diagram. What are the forces acting on this object? Get the obvious one. Gravity. Now, for me to ask you this, I have to tell you which way this object is moving. And I'm going to have to change this question next year because here I said the object is accelerating downwards, but I got to be honest, even if it's moving up, it is accelerating downwards. So next year, I added this question this year. Next year I'm going to say has a downwards velocity. But I think most of you assumed that it was moving downwards. Which way would air resistance be? Up. Did anybody have air resistance pointing down because they assumed this was moving up still? If you did, I will have to give you full marks. Nobody did? Okay, good. But still, that's sloppy writing on my part. I have to fix that. Yeah?
You said free fall. You have to be falling down.
No, you don't. On the way up, you're still in free fall. This is in free fall on the way up and on the way down. And both times, it's accelerating downwards. On the way up, it's traveling up but slowing down. That means it's accelerating downwards. On the way down, it's traveling down and speeding up. That means it's accelerating downwards. What did change in direction technically was air resistance. But I think most of you came up with that. Tato, who's winning? Oh, sorry, I forgot to label this. Air. Hang on, we got a latecomer. Let's try that again, Tato. Who's winning? Minus F air equals MA. Winner minus loser equals MA. What did they want me to find in this question? Oh, how to get the A by itself. Now, I have no problem if on this line you decide to go. You can also rewrite the whole thing, and I'm fine with that too, but you know I tend to abbreviate. So A is going to be M, 0.62. G, 9.8. I don't need the negative because I let down be positive this time. Minus F air, 1.4, all divided by 0.62. It's going to be a little less than 9.8 because air drag is actually slowing this thing down. 0.62 times 9.8 minus 1.4, close bracket, divided by 0.62. You get 7.54? Technically, I guess 2 sig figs, 7.5. All right, 7.54. Units, it's an acceleration. How would I give up part marks here? I would probably do something like this. I would give you 1 whole mark if I saw that. Half mark for the numbers. Half mark for the answer. Then I would go to the next page. Matt, what does number 3 want me to find? Did you say net force? That is a trigger word. If I say net force, you can go straight to saying, you know what? F equals MA. I don't need to go free body. I don't need to, F equals MA. Oh, we're done. Well, then this is 2 marks. Maybe it's multiple step. Did they give me the mass? Yeah. Did they give me the acceleration? Oh. So even though this question said find the net force, what does this question really want me to find? And I'm going to spend most of my time doing that. I'm going to, how about like that, because I think I don't need much room to go MA. So, talk me through it. Absolutely. I love the way you rolled your eyes and said that's the obvious. Hey, a couple of months ago for us that was a stretch. Now we're getting much better. Good. What's this 15? Yep. What's this 85? Yep. Technically a displacement, but like you, I've taught you to be sloppy with that word. It's a bad habit I have. Bad habit I have. A little Lord of the Rings Freudian slip there, right? Next. Yeah, sure. Oh, you're going to get the A by itself already? Oh, you just made my day. Okay, go. You go. Go. I agree. So it's going to be 15 squared minus 0 squared all over 2 times 85. I doubt this is going to work out evenly. Did I bother typing the minus 0 squared? It doesn't make a difference, so I didn't bother now. Hopefully we're okay with that now. 2 times 85. You get an acceleration of 1.323529. I'm going to write 1.32, but I'm going to use my answer button over here. And let's take it home, Matt. What's the mass? 1.32. 1200 times answer button. Do you get 1588? I'm going to just go to 2 sig figs and call it 1600. But if you said 1588 or 1590 or whatever, but I think this is a 2 sig fig question. So I'm going to write F equals 1588 equals 1,600 newtons, but I'd take that. In terms of part marks, I would give you a half mark if I saw that. I would give you a half mark if I saw that. I'd give you a half mark for the acceleration, and then a half mark for the answer. I like number 4. I like number 4. I like number 4. Number 4 is a nice question. Max, how many marks is number 4 worth? Not 2? 3? You know what? I'll bet you I'm going to find something and then use that to find something. I think it's going to be like a 3-step question. What's number 4 asking me to find?
Final velocity.
I got to be fussy. I didn't say final velocity. Yeah, reason is technically velocity should have a direction component, like north or south, whatever. So final speed. So you're saying it wants me to find VF? Okay. Matt looks at me and says, Duick, VI is 0. D is 16. I think I need this. Even though this question is asking me to find the final velocity, I think I'm going to end up spending most of my time finding the acceleration. I see 56 newtons and I see friction. Is there more than one force in this question? This is going to be a job for a free body diagram. You could do it right on here. I'm going to do it down here. So let's see. What are the forces acting on this block? Obvious one. Gravity. It's not sinking into the ground like quicksand. It's not flying into you like Superman. I have an applied force of 56 newtons and friction. Who's winning? F applied. Who's losing? Friction. What does winner minus loser always equal? MA. Oh! So the acceleration is going to be F applied minus friction divided by M. That's going to be F applied minus mu times the normal force divided by M. Ah! I don't know the normal force. Oh, but look. I know another force the same size as the normal force. Which force? mg. So you're telling me actually I can just replace that with an mg? So it's going to be, running out of room here, 50, was it 56? 56 minus 0.24, what was the mass? 12 times 9.8 divided by 12. I'm going to get an acceleration of, hang on, Duick, bracket. 56 minus 0.24 times 12 times 9.8 divided by, let's make that look like a 1 and not a decimal, 12. I got an acceleration of 2.314 and then the 6 starts to repeat. So I'll write 2.31. I'm going to take this answer and use it over here. I think here I'm going to go VF squared equals VI squared plus 2AD, and I want to get the VF by itself. Oh, how would I get rid of a squared? So VF is going to be the square root of 0 squared plus 2. I'll write 2.31, but you know I'm using my answer button there. D16? Okay. Kiana, is the 0 squared going to make a difference at all to this? I'm not going to bother writing it. It's going to be 2 times answer button times 16. Dope! Let's try that again. 2 times answer button times 16. Yes, yes. Square root of that. You get 8.6? Woohoo! If you got that, 3 out of 3. Otherwise, I would probably give you, let's see, 1 mark if I saw that, 1 mark for finding the acceleration, 1 mark for finding the speed. Actually, I'd break it up into part marks on a test, but that's a start for now. Is it turn the page time? Yeah? Oh boy, Mr. Dewick, that is such a work of art. Well, thank you. I mean, I captured motion and everything. It just looks like I freeze-framed somebody, right? Okay. 3 marks. It wants me to find her acceleration. All right. What are the forces acting on this here skier? Get the obvious one. Get the obvious one. Yep. And I think normal force up, and I don't think there's any other vertical forces. Now, I can't remember if it was this block. Somebody asked me a good question. They said, Mr. Dewick, it says the skier exerts a force of 110 newtons through her ski poles, but Mr. Dewick, she pushes backwards. Shouldn't that force be pushing backwards? Shouldn't that force be pointing backwards? What does she push against with her ski poles? The snow? How big a force does she exert? If she pushes against the snow with 110 newtons, what does the snow push on her with? 110 newtons forwards. And I'm drawing the free body diagram on the skier, so the 110 newtons would end up pushing forwards because it's a Newton's third law, forces come in pairs. Friction. Okay. Who's winning? The applied force, 110. Who's losing? Friction. That equals MA. How would I get the A by itself? I think I'd divide by M. The 110 would drop down like a domino. The minus friction would drop down like a domino. Divide by M. (110 minus mu times the normal force divided by M. Yeah, I don't know the normal force. Oh, but look. I don't know their force the same size as the normal force. Which force? So I think I can go like this. 110 minus, what's mu? I don't know, what's mu with you? 0.11, that's about right for snow. M, 47. 9.8 divided by 47. $1.26. Thumbs up. Yeah. 1.3. I'd take that. Well, how many sig figs should I go to in this question technically? I guess 2. So I'm going to write 1.3 meters per second squared. If you got that, 3 out of 3. Otherwise, I would probably go something like this. 1 mark for that. Half mark for that. Half mark for that. Half mark for that. And a half mark for the answer. I think that adds to 3 marks. I think, Sarah, I would... Hello. I think. What force is required to move the box across the floor at a steady speed? I think this is a job for a free body diagram. Gravity down, normal force up, the applied force, and I think that's what they're asking me to find. How hard would you need to pull? Oh, but if I'm pulling at a steady speed, friction must be slowing me down at exactly the same as the applied force is accelerating me forward. Who's winning? It's a tie. So you could right away say, well, the applied force, which is what you're asking me to find, equals friction. Friction is what times what? Well, it's mu times the normal force. Yeah, I don't know the normal force. Oh, but look. I know the force the same size as the normal force, mg. So I can say mu mg. I think we're good to go. The applied force is going to be, what's mu? I don't know. What's mu with you? 0.32, 20 times 9.8. Is that right? 0.32 times 20 times 9.8. You get 67.72. Sorry, 62.72. Did I say 67? 62.72. 1, 2, 3, 4, 5. How about 1 mark for that, half mark for that, half mark for that, half mark for that, and a half mark for the answer. But if you got it right, you get 3 out of 3. Can you give yourself a loverly score out of, is it out of 15? 2, 4, 6, 9, and 6, 15. Yes, it is. Can you give yourself a score out of 15, please? Last day, we started looking at what we called many body problems, and I gave you a whole raft of homework, and I did say I think I would give you some time to work on this in class, and I will. I'm going to start the next lesson a little bit, and then I'm going to pause, and you'll have some time. But what did we say? We said, look, if you give me more than one mass, the only tweak that I need to do is I need to tweak my winner minus loser equation. If I have more than one mass in my winner minus loser equation on the left-hand side, I better have more than one mass in my winner minus loser equation on the right-hand side. And I gave you a big raft of questions to try. I think it was basically, we skipped 4, and I assigned everything else. And some of these were nasties. And I'm prepared to take questions about them. What I'm going to do first, though, I think, is start the next lesson for like 10 minutes, and then I'm going to press pause and give you the remainder of class to work on the homework, okay? It's a little disjointed. So we're going to look at something called the Atwood Machine. But first, I want to show you a short video. You might recall way back when we started first looking at acceleration, I told you that our bodies are backwards accelerometers. When your car accelerates forwards, which way do you feel like you're getting pushed? Backwards. When you hit the brakes, which means you are accelerating backwards because you're slowing down, which way do you feel like you're getting pushed? Forwards. When the elevator accelerates you up, which way does your stomach feel like it's moving? Down. When the elevator accelerates you down, which way do you feel like you're about to fly? Up. And when you go around in a circle, you feel like you're getting pushed outwards. Which way are you actually accelerating? You are. Your body is a backwards accelerometer, but it turns out not everything is. Here's an experiment that you can try on your own. Put your pencil down. We're going to go for a few minutes, and then I'm going to pause. Ladies and gentlemen, the Atwood Machine. What's the Atwood Machine? The Atwood Machine is a pulley system as seen below, or if you look up, this is an Atwood Machine, where you have 2 masses on the end of a rope connected by a pulley. Now, in my little toy, I don't have a pulley here, but you can use your imagination. Oh, except it's magic. Our pulley has no mass and no friction, because that would make the math hard. We would need calculus. Oh, and our ropes have no mass either, because that would change the equation and we would need calculus. So we're in our magic physics world where everything works out nice, where I often ignore friction and air resistance. Having said that, Kiana, this actually has some really nice physics applications. This is basically how elevators are set up. Most elevators have one mass, that's the car, and then they have another mass that's a counterweight. In fact, typically the counterweight will be exactly the same mass as the empty car, so that all the motor is actually doing of an elevator is lifting the people. It's not having to bother lifting the empty car. Smart idea. Okay? So, the Atwood machine I wrote is a pulley system as seen below. Here's my lovely little handy-dandy schmandy picture. Mass 2 makes it easier for a person or a motor to lift mass 1. Mass 2 is called a counterweight. Here's our first little thought experiment. It says this. Supposing equal masses, identical masses, are placed on both sides of the Atwood machine, and one mass is lifted up high, like this. And then, when I let go of this higher mass, if there is no friction in this pulley, what will happen? A, the system will remain at rest. B, the higher mass will fall down because of gravity. Or C, the higher mass will go higher because this one's closer to the ground. You know what? Once again, this is a chance for us to vote. Once again, how high we hold your hand up is how sure you are of the answer. So here's what we're going to do. We're going to start off dead level, and then I'm going to say to you, what if I raise one of the masses up higher and let it go? Now, if I let it go here, there's a lot of friction here, so maybe this is not accurate. But what happens? A, nothing. B, the higher one comes crashing back down to the ground. Or C, the higher one keeps going higher. Got the question? Who says A, Mr. Dewick? A is correct. I think nothing's going to happen. A. 1, 2. Brees, was that a... You sure? Okay, that wasn't a smooth little no vote. Okay, 2. Who says B, the higher mass is going to come falling down, Mr. Dewick? The higher mass is going to come falling down. 1. Who says C, the higher mass is going to go higher? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Wow, lots of you. You know what? I think this is a job for a good free body diagram. I think if we do a free body diagram, we'll actually be able to figure out which answer must be correct. So I'm going to look right here, and I'm going to say, what are the forces on this object here? Get the obvious one. What else? Tension. What are the forces acting on the right-hand mass? Get the obvious one. Gravity. Now, normally I'd call them M1 and M2, but did the question say both masses are identical? Yeah? So I'm going to call them both M. Oh, what else is acting on the right-hand mass? Tension. Now, most of you picked option C. Yes? So those of you that picked option C, I think you're saying this is winning? Because it's going to go down. Okay, so let's decide that's loser, that's winner. Who's winning? You all said, those of you that picked option C said mg. This tension here, winner or loser? Loser, so minus tension, because it's pointing up. Now this tension is also pointing up, and you might be tempted to say that it's a loser, but if you follow it all the way around, if you follow it, which way does it end up pointing when it gets to this side? Which we've decided is a... Okay, cool. And this mg is pointing down. You might be tempted to say it's a loser, but if you follow it all the way around, which way does it end up... Sorry, you might be tempted to say it's a winner, but when you follow it all the way around, which way does it end up pointing when it gets to this side? Which makes it a... Okay. Is there more than one mass in this question? Yeah. So, since I have masses here and here, over here, I would have more than one mass. I would go m plus m times a. You okay with?
Can you write 2m?
Yeah, I would actually probably write 2m times a, but we'll get there next. All right. I always find these questions relaxing. Oh, wait a minute. Something else kind of strange happens here. What else cancels on the left-hand side? Don't I have mg minus mg? So if everything cancels, what number is left behind on the left? 0. So we get this. 0 equals 2m times a. How would I get the a by itself? Divide by 2m. When you go 0 divided by a number, what's the answer? Now, I know you can't divide by 0. That's not what we're doing. When you go 0 divided by a number, what's the answer? As a number, what must the acceleration be? What must the correct answer be then? Which of those three possibilities is the only one that satisfies not accelerating at all? Option what? Tato and Zach, nice job. You raised your hand for option A? I'm sorry, I only wrote down 2, did I? Or did I write 3? Okay. Explanation? Honestly, right there, I wouldn't use any English. I would do a free body diagram, and it pops out naturally. By the way, this is also hugely handy because here's what it means. Remember I told you elevators use this system? That means if an elevator is sitting empty on the 3rd floor, no energy, no electricity is required to keep the system at rest. You're not having to burn any electricity. You're not having to use the motor. It'll stay there. You're only using electricity when someone gets in. It's a good, efficient system. This is the Atwood machine. This is just for my own records. How many of you have not finished lesson 5 yet? Raise your hands. Okay, so work on that for the remaining 15 minutes of class. And I got other videos and stuff.